be speaking about today I will be speaking about a few points, very, very important, that we continue to hear about quantum computing and the threat. Actually, I would like to share some insights regarding understanding quantum computing business applications, because it's very, very important not to understand only the threat and what's coming and all the buzz that we hear. Some are saying it's hype, others, they are scared. And we see that governments around the world, states, they are taking initiatives in order to have policies and laws and procedures to protect their national interest when it comes to quantum computing threats, and of course the countering of the capabilities of the friends and foes, always I say. So I would also talk about the threats, of course, from general points, which is touching upon the national security and cybersecurity, and how to prepare the future workforce, or what I say, the workforce of the future. And the main point we hear about is the quantum revolution 2.0, and the moving forward to a new era, which is the quantum leap, what I call it. And the quantum revolution 2.0 comes so much now by the words, the quantum field, and what it indicates. Before we hear so many people speak about quantum leap and about the sophistication of this word, and it's futuristic, that has been used by TV series and sci-fi movies. So it may come as a surprise today, and probably is not surprise for so many who are in the cybersecurity world, that the reliance upon quantum phenomena is not new. Actually, since the 1950s, quantum phenomena has been employed by the creation of lasers, semiconductors, and technologies that led to the current technologies that we have today, and computer technologies, of course. So although past quantum technologies employed quantum processes engineered, could frequently talk about the technologies from a term of bits of informations. So today we are hearing more about the terms that it's related to qubits. And today with the quantum phenomena, we are employing this phenomena in order to store, process, and analyze the new sort of information. So the quantum information science revolution, which includes quantum computing, of course, we have quantum communications, which is very, very important type of field, and quantum computing, of course, quantum sensing, and quantum simulations. So when we talk about quantum computing or quantum sensing or quantum communications, there are game changers with the revolutions that we are witnessing today. So it is across many industries, including health industry, energy, and new material, insurance industry, aerospace, and defense, of course, which is the main industry that right now is making stepping stones in order to go toward supremacy when I talk about international relations. And of course, finance industries, telecommunication, and media industry, among others. So three main areas of quantum technologies that are moving forward, as I said, and I will try to introduce quickly each one of them because they are interrelated and very important for cybersecurity, of course, and I will elaborate later. So the quantum computing is a new technology for computation, which leverages the law of quantum mechanics to provide exponential performance improvement for some applications. And quantum computing today is able to do, let's say today, I say like that, because actually there are powerful quantum computing, but not to the point that it will go forward to what we aim at. So it is potentially capable the future, when it's mastered, the future technology, when it's mastered, and here we talk about the number of qubits, the quality of qubits, and how it can be scaled up. So it will be completely new, touching new territories, and some of the early quantum hardware products are special purpose quantum computers, also called quantum simulators, which are very, very important, and they will be game changer in the science and new material and all other fields that they are needing for simulation in order to achieve a competitive advantage. And when we talk about quantum sensing, is the new generation of sensors, because we had before the generation using quantum technologies, and built from quantum systems. It could provide measurements of various quantities and so on. So the quantum communications is the secure transfer of quantum information across space. And most of the time, I give the example of the Chinese example, which they are beaming quantum communications. They started since 2016, and that's very, very interesting in order to see the next generation of communications, which will be game changers, and already it is today. So the quantum computing itself, when we talk about business opportunities, it could be, or it has the potential of accelerating complicated computational applications with quantum computing, with the potential to solve problems previously thought are as unsolvable. So for information processing and calculation, quantum computers use the quantum bits, as I said before, or qubits, which are roughly comparable to the standard computing bits, but of course not the same, and far more versatile and not the same. So we talk about the normal computers or conventional computers, they work 0 or 1. Here we talk about, some people, they say 0 and 1 at the same times, but other scientists, they say between 0 and 1. And it's actually kind of tricky a little bit, and I'm not a scientist in order to explain that, but it's worth knowing, and that's why I'm here today, in order to raise awareness about quantum computing and its potentials for cybersecurity experts and professionals, and how they can be the future workforce who are the guardian, and how to prepare for that in order to add a competitive advantage to their national security within their countries and be at the forefront of this kind of revolution. So here I will also add that when we compare to the systems of quantum computings, actually it's not even comparable to the normal computer today. And that's why I will go to the next step, which is talking about with quantum computing, what we can do, or what is the potential, because actually we have quantum computers today. Actually, I advertise on, and I don't like to advertise here, but I will say that I have in my office 2 qubits NMR quantum computing, which is the first generation of quantum computers with 2 qubits, and it is used for education. And here, when I look at the quantum computer, I see a small little microwave, actually not a microwave, but it looks like a microwave. And there, it's like, it's unbelievably, years ago, I was speaking about the future of quantum technologies and quantum computing, even before IBM come up and Google's and all these big tech, they come up with their findings and they start publishing papers. I was looking at it, it's the future, but it's not the near future. Here, when I look at the quantum computing with 2 qubits, I'm like, wow. Here I have in front of me the quantum mechanics and this qubits working and everything in front of me, and it's real quantum computing. It can simulate up to 8 qubits, but it's real quantum computing. So now we are talking about how these computers can scale, or how quantum computing can scale. And if it reached to a very, very high number of qubits, here it can be more powerful than any supercomputer, or it can do what, like this kind of technology. It can make like things that we never imagined before, and we are not there. But the thing is, like, how can we prepare? Preparation comes from policies and future foresights, and countries are planning in order to be at the competitive edge and put fundings, investments, but also future skills is very, very future skills formation, and forming the workforce of the future is very, very important. So today we talk about quantum computers have the potential to fasten the progress of other key technologies like artificial intelligence. And I talk about machine learning. And we see now ChatGPT, what it's doing. Can you imagine if we have computers more powerful than supercomputers, with the power of those computers, what we can do with machine learning? So additionally, quantum computers have the potential to make a revolution in science, like I mentioned before, particularly when it comes to new material. And it's very, very important, because actually when we talk about new material and simulation, even with the chips and semiconductors, we know very well it's very, very difficult to get into the final products. It goes through many, many processes and trials and errors, and to come to innovative ways in order to get it into the capabilities that it can be input in new system and quantum systems in general, so or in particular, and their simulation and new material, very, very important. So however, you see me now talking about the quantum computing business opportunities, or what we can do with it, is very, very important, because actually it will open a great like new ways of seeing the world and changing the world. But it is important to understand that the more we are going there, more the cybersecurity ecosystem need to be ready, because you are the guardians, like I said before. So I go back a little bit to explain that the quality requirement of those quantum computing that will be able to do all this, it is critical to build a practical quantum computer. With quantum computers, with those practical quantum computers, we will be able, like I said, to do things we never could have imagined before, things that not even most powerful supercomputer can do. So we're going there. The potential to fasten the progress of other key technologies rests upon this technology right now. So we go to the part as to check quantum computing technologies, why it is important to business, or why it's important for business. And here, cybersecurity today is very, very important against economic espionage, because actually now there is a big race, and all the countries trying to have a peak of what the other countries or government are doing in the larger scale, which has an implication on security and defense. And of course, you have the rogue actors, whether they are states pushed in order to do cyber attacks or economic espionage, in order to understand what the others are working on, and what is the findings, or what are the innovations in this kind of field. So here you can understand the implication and the importance of quantum technologies on different sectors. So I talk about key verticals that quantum computing will impact the most. Of course, cryptography, which is the most outlined security currently, depends on the difficulty of factoring large numbers into primes. Then we have financial modeling, very important, this vertical, because randomness inherent to quantum computer is dependent to the nature of financial markets. So it's very, very important. So the other field, or the other vertical that quantum computing can leverage, is the weather prediction, which is equations governing the weather, possesses a hidden wave nature, which are very important and can create solutions also with the quantum computer efficiency. Then when we talk about particle physics and easy to model how these modeling to achieve or to know physics problem or to solve physics problems. And here I will touch upon the aerospace industry. It's very, very important when it comes to very difficult physics issues that can be solved through quantum computing. And then also transportation. It is very, very important to know that, of course, the traffic management and having a safer traffic system is very important. And we saw the issue that happened not long ago in the United States with the aviation traffic, and it was trouble. But if we had a very efficient quantum computers, these issues can be mitigated. And this shows how this technology is indispensable for the future of our of humanity in general. So other important aspects of quantum computing for businesses, it's related to power efficiency. It's related also to processing power, also robust intelligence, speed up learning process of AI, and reducing thousands of years of learning to seconds. And this is the power of quantum computing. The others, so many others that I can cite, but due to the time constraints, or I will recap. There's one more thing: is compute supremacy allows for the surpassing of any and all limits that traditional computing has set for us. So those are the areas and the why quantum computing very important, and to keep watching and keep an eye, and why it's important to dive into this ecosystem and knowledge and get the skills that I will go through briefly later on. So here we have near-term impacts of quantum computing, because actually there are some companies are working on applications that can be optimized in order to achieve a competitive advantage through quantum computing. And here I talk about the applications that can be related to key segments like oil and gas, sustainable energy, chemicals, and the other ones. And here they are, let's say we talk about from like 2025 up to 2030. So how they're going to be heavily impacted. Then when we talk about the quantum technology or quantum computing application or use in the pharmaceutical and medical products, and here it's very, very important because it can be disruptive, and its significance is already started being witnessed by the experts in this area. So also so many other industries can be impacted and positively impacted, and at the same time, when you talk about an industry can be positively impacted by quantum computing, it's the opposite also is there. It depends who's going to be there first, who's going to achieve the supremacy first, and who's going to harness this technology first in order to move forward and have this giant leap toward the future. So quantum computing is expected to catalyze economies within the near-term impact, and we saw that in so many reports. And actually, I can cite few. For example, the one that I just spoke about, it's a McKinsey report, and I have the source that I can share on the chat section. And of course, like I said, automotive, banking, defense sectors, also chemical and pharmaceutical sectors, as quantum computing-based modeling of molecular processes may replace the lab-based testing. And this is another thing. Actually, all the investment that could be done in a very super advanced lab can be done through the quantum computing based modeling of these molecular processes. So when we are touching upon threats, and here one of the biggest threat, which is the threats of quantum computing on national security, imagine those power or the power of quantum technologies or quantum computing in particular in the hand of a rogue organization, in the hand of an organization which is a terrorist organization, or in the hand of rogue state. And when I say state, it's country. So it's very, very alarming. And before, I used to raise the alarm because actually I went through researches and what is the possible and everything. Some people, they laughed at me. It's like, okay, this is not going to happen. There's no quantum computing is going to be there, or they're not going to master it. The technology is a little bit advanced and we don't have the means for it. We don't have the systems for it, and we don't have the chips and this and that. Today, we are achieving milestones to make it happen. So quantum computing, when it comes to national security, and when it comes to national security, we're not going to wait for these to happen. It's a planning of a state in order to protect its national interest, and also the interest of the allies, because actually it's important when it comes to international relations and you are in an ally organization and or pacts or international treaties in order to create a kind of like NATO, for example. It's important to have joint vision and joint action in order to move forward. So when again, quantum computing has the potential to make a revolution, the way we process and store information, but it also possesses a significant threat to national security. As quantum computers become more powerful, they will be able to break through traditional forms of encryption, leaving sensitive government and military information vulnerable to cyber attacks. And the ability of quantum computers to process large amount of data quickly could also be used for malicious purposes, such as the prediction of military strategies or hacking into financial systems. The growing threats of quantum computing is national security highlights the importance of cybersecurity professionals to acquire new skills, new way of thinking in order to combat this new type of threat or cyber threats. Here, I'm going to give an example, another example. When we talk about cybersecurity and critical infrastructure, and we talk about nuclear plants, if a rogue state or organization has the possibility to hack into the system and put its, when I say put its hands or get into the nuclear information of another country, this is big risk, this is big threat, and we shouldn't wait for it until it happens. Otherwise, we will find ourselves in another situation where we had issues with nuclear problems. So that's one of the examples, probably to bring the attention for the gravity of the situation and how we can mitigate the risk. Because the thing is here, I'm not trying alarming. It's like, how can we manage the risks? So the quantum computing ability to process large amount of data and perform complex calculations makes it amazing tool for breaking traditional forms of encryption. Amazing in the form of being surprised, but it's not amazing for what it can do. So anyway, this means that the sensitive government and military information, such as, like I said, classified documents, communications, and other military secrets, could be easily accessed by cyber criminals and foreign governments. And it is, that's why quantum computers have the ability to perform complex simulations also, which could use to predict the, like I said, the strategies and others, military tactics. So one of the most significant concern about the quantum computing, like I said, it's the encryption. So as you know, I mean, I'm talking to cybersecurity people. You are better than I do understand in the encryption and the techniques used behind it to protect the data by converting it into codes that can only be deciphered by someone with appropriate keys. Today, what they are doing when they are making cyber attack, and even if it's encrypted, what they are doing, there is this thing they are saying, steal today, decrypt tomorrow. So this is a thing, keeping the data for later on in order to decrypt, and this will happen with quantum computing. So this is one of the other reasons why it's very, very important. And in conclusion to this part, quantum computing has the potential to make a revolution in so many fields and in the field of computing, and bring many benefits that I cited. Few of them, I can go on. But however, the ability of quantum computers to break encryption has significant implication for the national security and the international security in general, and for government's operations. So it is essential that national security community and the cybersecurity professionals are aware, and they are working toward hands in hands in order to mitigate or manage the risks that by taking the necessary steps to mitigate them. So here, one of the steps that it's very, very important is preparing the workforce of the future, which is crucial. So the skills that cybersecurity professionals must acquire in order to address the threats of quantum computers to national security and to the security in general, which is one of the let's say, the risk management spheres or element that it is very, very important, is to have the human capital in order to do that. And for example, we have, I have known some cybersecurity professionals who are now interested in understanding the fundamental principles of quantum computing and quantum algorithms, which is essential for developing strategies to protect against quantum attacks, which is the quantum computing theory in general. To grasp the idea of it and understand it, it's very difficult. I tried, I took classes and everything. And when you say, if you think you know quantum physics, you don't know anything, because actually it's very difficult. But this one is something to understand, at least the fundamental principles, in order to grasp the difference between the conventional computer and encryption and the other ones. The other points that it is critical to understand and to have the skills for is quantum cryptography. This field involves the use of quantum mechanical properties to secure communications and protect against any eavesdropping. So professionals they have to understand the principle of quantum key distribution, or QKD, quantum secure direct communication, and quantum encryption. So the other part is the quantum safe cryptography, which is involving the development of cryptographic algorithms that are resistant to quantum attacks. And this is what most, they call it the post-quantum cryptography. Some other, they don't like the word because they say it's not post-quantum, it is quantum-resistant cryptographies. So it is the understanding of the mathematical concepts such as, you know, number theory and complexity theory to develop and implement these algorithms. So the quantum safe protocol is others that it's to understand it is to be able to design and implement secure protocols that are resistant to quantum attacks. And this including understanding the principle of quantum safe key exchange and authentication, or quantum safe authentication, and quantum safe secure multi-party computation. So the other one is quantum safe hardware. It's very, very important. And actually, I know very well my cybersecurity friends, they say actually the software is very, very important, but the hardware is as important as, because it comes, and this one, it comes to satellite. When it comes to satellite security, I always hear them, they say it's very important to have the protection of the satellite in terms of all the algorithm or softwares that you use, but actually it starts from the hardware side. So this one is the design of the knowledge of software design principle, and be able also to design and implement quantum safe software which is compatible with the hardware itself, that it has the component for it. So like I said, I'm not a scientist or a person who is into the hands-on elements of this quantum computers. But actually what I say, and I say in every conference I go to, I say I pick up the problems, I grasp the problems, I bring a team together, and that team is working on, each one is working on what he is the best at and the best of the best, in order to bring together solutions to the problem through consultancies, through creation of solution in the future. But there is one thing that I took the initiatives for, and it is related to skills, and related to training, and related to knowledge acquiring, and it's related to how to prepare the future experts in order to mitigate risks. And it starts from younger age, and that's why it's very, very important to have different elements from the quantum physics in order to start with, going to quantum cryptography. And there's something I wanted to end with. It is very important to know that today the ecosystem is shattered. So what's happening? You have the people in quantum physics with the physics backgrounds, and they are very good at what they do, and we appreciate them so much, because we go to them in order to understand the basics, and we're not trying to be physicists. But you have also the software engineers who don't understand the quantum physics, and try to work on the post-quantum cryptography, and I'm not going to say it anymore, the quantum resilient cryptography. But they are suffering to understand the elements that needed or necessary from the quantum mechanics itself in order to do it, and so on, because it's a cycle, and it's a circle. And actually the most important thing for cybersecurity professional is to be around and to get out of their bubble in order to understand more and to acquire more knowledge, because it's never late. And actually, once you are today at the forefront of this, let's say growing, because it's still baby, growing ecosystem, which is the quantum ecosystem, you're going to be the leader in years from now, when in 2025 or 2030, what's going to happen, it will be totally different than today as we know it. And you saw NIST new standards, and you saw Biden administration work toward the new era, and how to protect the US national security. So that's very important, is to get out of the bubble and to try to get out of the cybersecurity ecosystem in order to understand others, and to continuously stay informed and educated about the latest development in quantum computing, and don't listen to so much negativity, or some they say it's hype, the others say not, or whatever. We are growing up enough in order to understand what's hype and what's not, and we have the skills which allows the skills which allow us to understand the actuality of things and what is happening exactly, to interpret and to analyze. Analysis is very, very important. So the other point is to stay ahead of the potential threats, which you do it all the time. I know cybersecurity professionals, they are always 2 steps ahead in order to be going forward and further than the other ones who are from the other dark side of the force, who trying to counter the capabilities today. So this requires a combination of both theoretical knowledge and practical skills in order to effectively protect the nation, protect the interests against quantum attacks, and mainly to protect the national security of the country, of the states, and international and global security. And by this, I think I got into my time. Hello,
And
Chris.
Malik, when it comes to some of the other benefits of, in addition to cybersecurity, what are some of the other benefits of the mechanical power of quantum computing in other areas? You're on mute.
Like I said, the simulation is very, very important part of the equation. Actually, even for hardware, for software, for hardware, for science, for astronomy, for you name it. If you can see everything that we are doing today, that it is based on experiments and it's based on calculations. Actually, like I said, quantum computers are actually much more faster than any supercomputer that we are seeing today. So can you imagine the power of that, what we can do with it? When we talk about we stay away from cybersecurity. We're going to talk, for example, about aerospace engineer, or we talk about climate change. It's my favorite topic. And I will go back to the aerospace. Actually, when we talk about the point that I mentioned right now, which is related to climate change, we are struggling to reduce the emissions and to meet the targets, which is 1.5 or 2. They raised the bar, but it's not possible to mitigate the global warming. This depends on clean energy and depends on so many factors that we can eliminate by making or by discovering a new way of or new energy. So carbon capture, all the kind of innovations, it will be possible because we don't have the means today in order to get into the way how we can discover new technologies with our computational power of today. So we are still working with comparing to the future of quantum computing, which we envision with thousands of qubits. We are primitives today. So this is the way how I see it. Maybe some people are not like they're not believing that it will happen. Actually, it will happen. The revolution is going further. And I remember, and I watched sometimes some videos of very well-known quantum physicists who are explaining the power of quantum computing and what's going to happen and everything. They were so skeptical. They did not even think that we will achieve 50 qubits at that time. They did not. They were not realizing the way how this technology is moving forward is fascinating, and it should be harnessed in a way that international relations are clearer than today, and it hopefully we will arrive to a point that we will have a universal quantum computing. I'm very optimistic, but I don't know about other people, and probably I will not see it today. I will not see it before I die. Maybe I will do. But at the end of the day, what I say to people, actually, we do the job for our children. We're not going to sit here and say it's not going to happen. We're going to say it will happen. How can we mitigate the risk given our human nature? And you know what I mean about the human nature. In a way, you have the bad and the good. You have the two sides. And how can we be there at the forefront of this disruption? Because at the end of the day, it is a disruptive emerging technology. And how can we harness it for the benefits of humanity? And if I will talk about its use for aerospace, actually, one minimum thing that I can say today, which is already put into place, the data that it is tracking, could track the space debris. Actually, if it's done in a way using some of the applications today, which is allowed by certain companies, that to optimize the machine learning or optimize the way how the data is tracked, it's already amazing achievement. Because there are a lot of problems with tracking the debris today because of certain anomalies. So this could take away that problems. It is tracked, but there is always a problem of anomalies and not accurate data.
Thank you for answering that. And one of the questions that I always think of with quantum computing is because there's multiple states of existence at any given time. When it comes to securing technology, how do we protect ourselves against a machine that can compute that many states at a time and still be able to protect ourselves?
That's what I'm here for. So it's very important because actually this is the preparation. If you go back to the President Biden, his latest, the memorandum that it was out, and everyone was in shock because so many were in denial about the ability of having a quantum computing, that it can be a threat to our all our information and data. It was, some people were in shock, okay, because they were always in denial that it could happen. So what I say, how can we protect ourselves, is first of all, there are the NIST chosen quantum resilient cryptography, okay, and also being ahead of everyone in order to find solution, because today even the chosen one, I think there were 4, yes, I believe so, by NIST. So even though it's not tried yet with very, very advanced quantum computing. So today we are talking about 50 qubits, 20 qubits, 400 or 500 qubits, 1,500 qubits, which was still we hear announced, but we did not see exactly that these quantum computing, what they are able to do. But like I said, it's the preparation now, is to work on preparing the workforce, and also follow up and being informed and follow up what the institutes and the governments, what they are coming up, or what they are sharing as information in order to get us prepared. We are part of the solution. We're not a part of the problems. We are a part of the solution. So this is the most important thing. And cybersecurity experts are the solution, along with this, with the physicists and experts who are into this kind of field, and computer scientists, the hardware engineers, and all these, putting together their efforts in a certain way that they can work together to move forward and protect the interest. Because actually, at the end of the day, there is it's very important to know that this threat, it's not one nation threat, it's not one cybersecurity company threat, it's not one person threat, it's a threat against humanity. If this technology is very advanced and it can be commercialized and in the hand of criminal organization, of terrorist organization.
Yeah, and what are some of the things that you're seeing that countries are doing to prepare themselves? I know there was the memorandum from President Biden, but are you seeing that countries are setting up educational tracks for individuals to learn and understand and program these quantum computers?
I see there is the awareness started growing. I remember 1 year ago, I remember this very, very well. When I used to talk about quantum computing, I was ridiculed. on social media. I was laughed at, and they say it's not true. And when different countries or states, they are announcing their steps ahead, others, they are in denial and they say it's lie. It's not a lie, and actually it's there, and the threat is there. So now, to going back to the educational part, I still don't see many of the universities in the world are working on specific curriculum which is related to engineering that can be quantum dedicated. This is number one. I do interviews. I'm looking for workforce actually to be in the academy, and I'm looking for everyone who is in any field that it's related to this one and can bring an added value in order to work together to educate the others. And it's very important to create a kind of consortiums to help each other and make the education going through. So I conducted so many interviews with physics professors. And before the physics professors, I will go to the other side, is physics bachelor's graduate and also master's graduate. Can you imagine that they tell me that they took quantum physics only in 1 or 2 semesters? With most of them. So it's something very, and they are very good at what they do. They can learn, they can do the things. They cannot go further into making the softwares or explaining about the softwares or explaining about other components, which is very, very important for teaching quantum computing. And this is a big lack. This is a problem. So we try to find ways in order to start with the education from younger age. My son is 14 years old. My son comes with me in the office, and like I said, we have the 2 qubits quantum computing. It has the courses embedded in it, and he's taken the course. He loves it so much because actually, he hates when I tell him do something. He's 14 years old. He's very rebel teenage. But there is one thing about it. He is very excited because the idea of seeing something that big, like I said, like a microwave, smaller. It's cute, but it's not like our computers today. So he sees it and he knows it's quantum. It's qubits, and it's NMR. It's the technology is not like the normal computer. So excited. And actually, when he comes, he asked me, "Can you open for me so I can take the lesson?" This is the thing that I see in his eyes, is the excitement. The 2 qubits, it's not very advanced in a way that is gonna decrypt things or make advanced softwares or whatever. And specifications are there, and we never say it is advanced to the point that, but actually it's that excitement that brings to students, to kids, to physicists. I have professors of physics. They came, and when they saw it, they have tears in the eyes, and it's like, wow, this is the quantum phenomena in front of us. And this is what we want to do, is all together. Yes, Aaron, actually they went crazy. It's like, oh my God, it's like one of them is saying, this is the precious, actually I gave this analogy. You remember, Chris, Lord of the Rings?
Yes.
Actually, that look, my precious, that look I saw in their eyes, that look I saw in their eyes, it's like, oh wow. And one is like, my precious. So it's that thing, that the excitement, we need to take look at what it's adding into the way how we can elevate us to a way that we can work together and to make this technology understood, and its threat is understood. And actually, more we have people understand it, innovation will go further. And one more thing I would add is, innovation is very, very important in this field, because this is how we can utilize the based on the knowledge and the education. This is how we can get into a point that this technology is harnessed to be used, optimize applications, and create based on it. Because actually this is one of the technologies that is game changer, just like artificial intelligence, but it's more. It's the base of what artificial intelligence can do with full potential. And here comes the ethical use of technology, and how, other than just national security issues and states are getting, into a race in order to counter the capabilities of the others. But there is something else which is very, very important, is how can we use it ethically and responsibly in order to move forward as a human being, as humanity in general, and not try to keep it for one nation or another. Actually, my main concern today is how the advanced countries will be using this kind of technologies, and what will happen to countries in Africa, what will happen to countries, underdeveloped countries, what will happen. And here, something else, we need to be careful to get this technology as a way of, getting these countries into the situation where they can utilize it. We need to be careful, because some countries, they have corrupt government like no tomorrow, and how we can protect us in general against those who can be using it in the name of developing countries, and give it to the hands of the rogue ones they have, who are behind with the corruption they have. And here I'm speaking about international relation and political science.
Well, thank you so much for diving into this topic. Really appreciate it. And we've had our last question. So thank you so much, and have a great night. And thank you for joining us. It was absolutely enlightening.
Thank you so much for having me. Thank you. I hope all you enjoyed it. Goodbye.